Welcome. Today we're working on is properties of exponents. So our I can statement for today is I can simplify exponential expressions using negative and rational exponents, and I can simplify exponential expressions using properties of exponents. Before we get started on that though, the first thing I'd like you to do is to take out your blue sheet that says exponent facts to memorize on top of it. And what I want you to do is fill in as many of those as you can without a calculator. And the ones that you don't know, go ahead and put a dot by those. And then when you're done filling in the ones that you already know, go ahead and jump or grab your calculator and work on those ones for a while and fill in the rest of your sheet. So you can pause the video now to go ahead and fill that in. All right, just quickly, you should have these numbers in here. It should look something like this. You got all your perfect squares, so 1 through 15, you should have those memorized, so all the way up to 225. Perfect cubes, we should know the 1 through 5 perfect cubes, and then some powers of 2s and powers of 3s. And then also, powers of 10, know these ones by knowing the pattern. So if you look at 10 to the first, 10 to the second, 10 to the third, and 10 to the fourth, the exponent tells us how many zeros we have in our answer. So 10 to the first has 1 0, so it's 10. 10 squared has 2 zeros, so it's 100, and so forth. But hopefully you have that filled out, and you'll take some time. We'll work throughout the chapter on making sure we have all those memorized. Going into a little investigation here, what we're going to do is we're going to take this product, 2 cubed times 2 to the fourth, and we're going to expand it, so write it in expanded form, and see what we end up with. So expanding 2 cubed, we have 2 times 2 times 2. So cubing something means we're multiplying it 3 times. And then times 2 to the fourth, 2 to the fourth is 2 multiplied 4 times. And so what we have here is basically, if we go through and actually count these, we have 1, 2, 3, 4, 5, 6, 7. So 2 cubed times 2 to the fourth is the same thing as 2 to the seventh. And if we have a tens here, so 10 squared is 10 times 10. And 10 to the fifth is 10 times itself 5 times. So 10 squared times 10 to the fifth is the same thing as 10 to the seventh. X to the fifth times x cubed is the same thing, x times x times x 5 times. So there's x to the fifth, and then x cubed is 3 more, which gives us x to the eighth. So our rule, and I just have this general form, a to the m times a to the n. Our rule is that if we're multiplying and these bases are the same, so we have to have the same bases. But if we're multiplying and the bases are the same, it's the same thing as saying we can add those two exponents together. So just like x to the fifth times x to the third was x to the eighth, a to the m times a to the n is a to the m plus n. We have another one here. So numerator and denominator of each quotient, I'm going to write out in expanded form. So the same thing we did on that last slide. And then we're going to eliminate some of our common numbers and see what we're left up with. So 4 to the fifth is 4 times itself 5 times, all over 4 squared, which is just 2 4s. And so I can go ahead and cancel 2 4s from our numerator and denominator. And we're left with 4 to the third, so 3 4s are in the top. We can do the same thing here. So x to the eighth times x to the sixth. So I have to multiply x by itself 8 times. Is that 8? 1, 2. Yep. And then x to the sixth. And if you see, we can cancel out all the way through here. We have all these x's until we're left with just x squared. So I'm going to jump ahead, and our rule for quotients then are when we're dividing. So a to the m and a to the n here, our general rule is going to be a, so we keep that same base again, to the m minus n. So what's in our numerator minus the exponent in our denominator. Okay, so 8 minus 6, 5 minus 2. So here we have more quotients in expanded form, and I'm just going to do 1 or 2 of these. So 2 cubed is the same thing as 2 times 2 times 2. And 2 to the fourth is 2 times 2 times 2 times 2. And if we go ahead and cancel, we see that we end up with more 2's in our denominator this time, so 1 over 2. So let's try 4 to the 5th over 4 to the 7th, see if that helps us anything. So 4 times 4, 5 times, and 4 times itself 7 times. And if we go through and cancel these now, we see we're left with 1 over 4 squared. And our rule says that we should end up with, I can make some room over here. Our rule says we subtract our exponents, our numerator from our denominator. And so we should have 4 to the negative 2, because 5 minus 7 is negative 2. But we got 1 over 4 squared. And our properties of exponents that we have here is that if we have a negative exponent, what we have to do is we have to flip our base. So instead of 4 to the negative 2, we can write it as 1 over 4 squared. So if we go down here, our rule, 1 over a to the n, is the same thing as a to the negative n. So negative exponents means we're flipping that fraction. We have a couple more examples here. So if we have a power raised to a power, so a squared to the third power, what this is it's going to be like a squared times a squared times a squared. So that's a squared cubed. And we can even break this down further by saying a squared is a times a, and another a squared, and then another a squared. And we have 1, 2, 3, 4, 5, 6 a's. So a squared times 3 is a to the 6th, and where that comes from is we're taking our exponent on the outside and multiplying it by the exponent on the inside. So a power raised to a power is a to the m times n. Similarly down here, so 4 times 3 to the 4th, we have 4 times 3 times 4 times 3 times 4 times 3 times 4 times 3. And if we think about combining some of these like terms, we have a 4 and a 4 and a 4 and a 4. And we have a 3, a 3, a 3, and a 3. So this is really 4 to the 4th times 3 to the 4th. So if we have some product inside of parentheses and we raise it to an exponent, we have to make sure we distribute that exponent, whatever it is, to both terms. So a to the n times b to the n. So we'll run through a few examples here. 4 to the negative first, we said negative exponents means we have to flip it. So instead of 4, it's now 1 over 4 to the first power, which is the same thing as just 1 over 4. X to the negative 3, so we can flip this, so 1 over x cubed is our final answer. And the next one, 3 halves to the negative 3, we have to flip this again. So we get 2/3. And now this is raised to the positive 3 power because that negative flipped our fraction. And now we take our 3 here, and just like when we have two numbers that are multiplied inside of our exponents, we have to distribute that cube to both of them. So we get 2 to the third over 3 to the third. 2 cubed is 8, and 3 cubed is 27. So there's our final answer there. So this next slide, I'm going to do the first one, and then we'll take some time to, or I'll give you some time to work on the second one. Simplifying this expression here, we have, look at the numbers first. We have a 2, and there's a 1 here. We just don't write it. And if we divide 2 and 1, so this piece here, we get just 2. Next, we look at our a's. So a to the first divided by a to the fourth. Remember, if we're dividing with like bases, we subtract the exponents. So 1 minus 4 gives us a to the negative 3. And then finally, we look at our b's. So b to the fifth over b squared. 5 minus 2 gives us b to the third. And one thing we don't want in our final answers ever is negative exponents. So instead of keeping this as a to the third power here, we're going to rewrite this as 2 times b cubed, and that negative exponent means we need to write this all over a cubed. And that'll be our final answer because we have no negative exponents. So go ahead and give the next one a shot. Negative 28 x to the fourth over 7x. All right. The first thing we can do is divide 28 and 7, or negative 28 and 7, and we get negative 4. And then x to the fourth over x is the same thing as x cubed, because 4 minus 1 is 3. These next two, I would like you to pause the video and give these two a shot. So we start out here, we have negative 3 over positive 2, and we can't simplify that fraction yet. So negative 3 over positive 2. If we look at what we have for our c's, c cubed divided by c to the 8th. So dividing means we subtract our exponents. 3 minus 8 gives us c to the negative 5. Oops, I didn't see if we had that square there. Let's go back. Let's go back. Let's go back. Sorry about that. First, let's start out and square this. So remember, if we have a squared, we have to distribute this to each one of our terms. So the denominator can stay the same. So 2c to the 8th times d. First one we can do is negative 3 squared. Negative 3 squared is positive 9. So negative 3 times negative 3. C cubed. We multiply 2 times 3 here, we get c to the 8th. And then the last one we have d, and then we multiply that by 2, so d squared. Now we can look at our like terms. So once again, we have 9 over 2. So there's our first part using the numbers. Now we end up with c to the 6th over c to the 8th. Again, it's a quotient, so we need to subtract these. So we end up with c to the negative 2. And then the last one, d squared over d. Remember, this is like d to the first. And 2 minus 1 gives us just 1, so we end up with g, just the d on top. Our answer here has negative exponents, so we don't want to finish with this one. We got to move those c's to the denominator. So 9d over 2c squared is our final answer. The next one here, we have a negative exponent on the outside. So first, let's flip our fraction to get rid of that. So y cubed over 8x is all squared now. So we have our positive exponent. And at this point, we go ahead and distribute our squared to all of these terms. So y cubed with our squared on the outside, so power to a power, we multiply those. So that gives us y to the 6th. Bring the squared down with the 8. So 8 squared is 64. And then x, and we have our squared on the outside, should be x squared. So that's our simplified answer. We don't have any negative exponents. We can't cancel any like terms, so that's our simplified answer. We have this one slide here that I want to do next. But you can pause the video and go ahead and try these ones first. All right, first thing is we need to distribute this cube to each one of these terms. So x to the 5th and then to the 3rd power. So power to a power gives us x to the 15th. We have to go this cube to negative 2. So negative 2 cubed is negative 8. And then y squared, and we're raising that to the 3rd power. So power to the power again is the same thing as 2 times 3, which gives us y to the 6th. Same thing for the next one. When you distribute this cubed in here, negative 4 cubed is negative 64. And then distributing our 3 to our ends, we have n to the 8th to the 3rd power. 8 times 3 is 24. All right, so our last few examples here. Here we have two different pieces that are multiplied together. So 3xy times 5x squared y to the 2nd power. So we have to decide which one we do first. And PEMDAS, our order of operations, say we have to do exponents first. So the first thing we do is distribute our squared to each one of those terms. So 3xy is going to stay the same. And then we end up with 25, so 5 squared. X squared becomes x to the 4th. And then our y's become y squared. And now we can combine like terms. So 3 times 25 is 75. X times x to the fourth, remember this is like x to the first. So x to the first times x to the fourth means we add those exponents. We get x to the fifth. Same thing with our y's. We add those and we get y cubed. And there's our final answer. Next one. We don't have any exponents out here, so we can do our multiplication. Negative 7 times positive 5 is negative 35. And then we have p to the fifth times p to the negative eighth. So 5 plus a negative 8, which is the same as subtracting. So 5 minus 8 is negative 3. And our last one is q squared minus q to the, or excuse me, times q to the fifth. We need to subtract the exponents because multiply them, add the exponents because we're multiplying. So 2 plus 5 gives us q to the 7th. And we have negative exponents in our answer, so let's simplify this. Negative 35 stays there. Q to the 7th can stay on the top, and then this p to the negative 3 becomes p cubed in our denominator. Okay. Your homework for today is a 6.2 worksheet. It's a yellow worksheet, and you'll have that for the weekend.